we have made it to a new chapter. We are in 10.1 statistical measures. We are going to be looking at some definitions. Today is very different. We are not going to be doing the math side of things. We're going to be talking in words, and your answers today are all word answers for your homework, so it's a little bit different than we normally have. But eventually we'll get to the number side of things. But before we get there, we need to talk about the definition and the verbiage behind what we're talking about. So first of all, we have this word population and we have the word sample, and these two we need to understand what is the difference between them. So as we read through these, think about what is the difference. So first of all, a population is an entire set of objects sharing similar characteristics such as human beings, automobiles, or measurements from which data can be collected and analyzed. All right, so a population, really key word here, is entire. Okay, so we would say all the citizens in the United States of America, that's an entire population. All of the students at Rapid City Christian, that is an entire population. All of the citizens in South Dakota, that is an entire population. All of the people in Pennington County, that is an entire population. Okay, now when we go to get data, so let's say we want to figure out let's just make it kind of not too serious. We want to figure out the favorite flavor of all of the citizens in the United States of America. Is it really practical for us to go to every single citizen in the U.S. and get a read on what their favorite flavor of ice cream is? No, that is not possible. We could not do that. All right, so we're going to instead use something called a sample. A sample is a portion of a population from which data is collected to estimate the characteristics of the entire population. So instead of going to every single person in the United States of America and asking them what their favorite flavor of ice cream is, we could pick, let's say, 1,000 random people from across the country and ask them, and then from that we could say something about the preferences of the entire population. Okay, now you guys can see this little visual. We can see that we have the entire population, and a sample is just pulling out part of that population. And that's often what we have to do in statistics. Usually we can't ask the entire population. Usually we just use a sample of the population. Okay, so the population is the entire set, and a lot of times this is a key word. All is a keyword for population. A sample is just a portion. We just ask part of those people to make it easier for data collection. Okay, so with that in mind, let's try. All right, looking at these 5 examples here, we're going to identify whether it is sample or population. If we look at number 1, it says a few junior high math teachers of the Christian school in Virginia. So looking at one school and a few of the junior high math teachers, would that be a population or would that be a sample? It is not all of the teachers in that school or even all of the math teachers, so we would just say it is a sample. Looking at number 2, a magazine wishes to determine the political view of college students, so it sends a questionnaire to all students at Union University. So they want to know the political view of college students, so they send it to all the students at Union University. Would this be a sample or a population? Now, I will let you know, with some of these problems, we could go either way, and we could explain it as such. For example, here we could say, well, it's going to all the students at Union University, so therefore it would be a population. It would be all the students. But we can also see here, it says they want to find the political view of college students. Are there more college students than the ones that go to Union University? Well, obviously, right? There's a lot of college students, so we could say this is just a sample. And in this case, it would be just a sample because we want to find if they said we want to find the political viewpoint of Union University college students, and we ask all of the Union University students, then it would be population. But since we're looking at the entire college student population and we're only asking the students at this particular university, it is a sample. Moving to number 3. Okay, so looking here, we can see we're looking at all the people who have eaten a hamburger at the Grill Zone. Now, it's hard to know because we don't know the entire reach of this statistical project, but we can see that we are asking or getting our data from all the people that have eaten here. So, since we're looking at all of the people, we would say that is a population. And again, all is a good clue word for us there. Number 4, 30 boys of various ages from a high school containing 3,000 students. So we have a high school that has 3,000 students, and we're going to ask 30 boys of various ages from that high school. Would that be the entire population or simply a sample? That would be a sample, right? The entire population would be all 3,000 students. But we are just asking 30 boys of various ages as a sample. So instead of asking everyone, we can ask a variety of people and use those answers to help us. All right, and number 5, all students that attend Rapid City Christian. Would that be a sample or a population? That would be a population. It represents the entire group of people. Now, could you say, well, that wouldn't be all the students from all Christian schools? No. And can a group be both a population and a sample depending on the study? Yes, but you'll notice they'll phrase it in a certain way to represent population or sample. All right. Now that we've talked about the difference between population and sample, we're going to move to the second half of our lesson, which just focuses on samples. When we have a sample, we're going to look at 4 types of sampling, and we're going to also look at examples, okay? So we have population and sample. When we're looking at sample, there are 4 main types. When we are sampling, so let's say we want to gather data, we can do it randomly. So examples of that would be a random number generator used to determine page number, column, row of each person in the sample. For example, if we wanted to get information on how often people go grocery shopping, we could assign each person a number and then pick, use a random number generator or something random to pick out people that we are going to call and ask that question. Completely random. Now, systematic means we have a system or a process. So example would be every 30th person listed in the telephone book is included in the sample. So let's say we want to find or ask a question. Let's say we'll do the how often do you go grocery shopping in a week. Then we'd go to a phone book or something, and we would do it systematically. So every 9th person there, we would call them. Every 13th person, or here, every 30th person. So it's a systematic process, not random, not where we're just drawing a number out or picking a random person. There's a system to it. 3, convenience. An example of this would be a questionnaire with a return envelope is mailed out with the phone bill. Okay, so that's an example of convenience. Another example of convenience would be some sort of online survey, right? So sometimes if you're watching a YouTube video, a survey will pop up. That would be an example of a convenience survey. Another example of a convenience survey would be just going to a certain place and asking everyone there. So let's say you are going to ask a statistical question, and you go and you stand outside the mall, or you go and stand outside a store, or you go to a McDonald's and you go around and ask everyone the same question. That would be an example of a convenient sampling method. Or cluster. Everyone whose address indicates that he lives in a particular section of town is included in the sample. So, for example, we want to figure out something about the people in Pennington County. So we go to a specific street and we ask everyone on that street, and we use that data to tell us something about the people in Pennington County. So again, a cluster looks at a group of people that's close together or has something in common to tell us something about the sample. And you can think about that word cluster, right? Like a cluster of grapes, they're close together. A cluster is looking at a group of people that are typically close together that can tell us something about an entire population. So random, systematic, convenience, and cluster. So with that in mind, let's try some examples. We have 4 examples to try. We are going to decide, are these samples random, systematic, convenience, or cluster? So starting with number 1, if we went and be asked a statistical question of all the young people in the church youth group, would that be random? Would that be systematic, convenience, or cluster? So again, with this sometimes there are more than one that seem like they could be right, but there's one best answer. Okay, so let's go through our list. First of all, is this random? Are we just picking random numbers and then calling or contacting them? No. Is it systematic? Are we contacting every 5th person? No. Is it convenience? Are we just going to a specific location and gaining that information? Yes, this one is convenience. Now, some people might say, isn't that cluster? Well, technically they are all together, but the difference there is that they don't live there, and that's not like a street or a specific neighborhood. Number 2, 50 Christian school principals are chosen from a list of principals whose schools are members of a large organization. Every 10th name is selected until 50 principals are chosen. So they have this list of principals, and every 10th one, they select that until they have a total of 50. Would that be random, systematic, convenience, or cluster? It would be, choose an answer, systematic, right? Every 10th, that's an example of a systematic approach to sampling. All right, moving to number 3. All the students in a large school are given a unique number. Okay, so if we took all the students in Rapid City Christian and we picked a number to assign each of them, and then we put all of the numbers, students' numbers are then chosen by drawing from a rotating drum containing pieces of paper, each with numbers on it. All right, so we put all the numbers in this drum and we draw out certain ones to sample. Would that be random, systematic, convenience, or a cluster? That would be random, right? We talked about having a random number generator. We can also use something like this rotating drum. Think of something like we put bingo in, right? That's what they're talking about when we talk about that rotating drum. All right, number 4, one of several 8th grade homerooms is polled about the school's concession stand menu. So one of several 8th grade homerooms. So in a bigger school, right, there would be several 8th grade homerooms, okay? And we're going to poll one of them about the school's concession stand menu. Would that be random, systematic, convenience, or cluster? Well, it's not random. It's not systematic. It's could be argued to be convenience, but this one is actually cluster. We're looking at a group of people who are geographically together, and so we would say that is cluster. All right, so we made it to the end of the notes. This is your homework. There are 8 problems. The first 4 are just like the first 4 problems, or first 5 problems we did together. You're going to identify these as a sample or a population, and then in these 4, you're going to identify them, these samples, as random, systematic, convenience, or cluster. And I'll see you tomorrow.